Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. Generally, when we talk about prominent aviation personalities and we mention rarefied air, we are referring, of course, to the high altitude flights that they may have made. Today, we are privileged to have a speaker whose world is in the rarefied air that exists in the highest levels of government and industry. As anyone in the industry can tell you, such people are vital to the success of any major undertaking. And so it is my privilege to introduce George Kivork. Also, we have someone whose work is in the rarefied air of test pilots, Brian Sandberg, flight test lead for Joby. Brian is the son of our own Jim Sandberg, who was the test pilot of our own YF-23. I'm sorry, I'm so fond of your dad. So we have proudly on display. So welcome, it's such a pleasure to have you both.
Good morning, good morning. Thank you everybody for joining us. Thank you, Cindy, for that introduction. That was wonderful, and really appreciate the opportunity to be here as both a historic location and to be part of a historic conversation. So again, thank you very much for this opportunity. My name is George, as Cindy mentioned, and I oversee the state and local policy at Joby Aviation, which means at some point, yes, I do feel like I'm in the air because I get to just talk to politicians all day to translate the complex work, the amazing work of decades that has gone into this electric propulsion technology, and to simplify it to local regulators, policymakers, as to what this means for their communities and what this means for transportation and what this means for aviation and what they're used to traditionally and how this will be a new era, if you will. Why are we here today? Besides a wonderful opportunity to be here on Saturday and see these incredible aircraft, we are at this unique moment in aviation. I don't come from an aviation background. I come from a city policy, political background, a recovering lawyer, spent a decade in city politics and federal affairs. And from an outsider, when I'm asked, why are you joining this? Why is this so important? I remind people that we are sort of what is now being defined as sort of the third phase of aviation. You had the creation of aviation, the magical transformation of flight. You then had the jet age, which then enabled us to connect cities and regions in ways we had not imagined before. And now we're in the electric propulsion age, which in my opinion is a moment of both accelerated safety and taking the traditional nuisances of aviation and transforming those and helping us reimagine the communities that we live in and incorporating aviation into those communities and changing the pie of who has been involved in aviation and the traditional aviation community. So what I'll do today is very brief, is mention who is Joby, what are we as a company, what have we built, and Brian will get into the real exciting part of that. And then conclude with what does this mean for you and how will we bring this to you as residents, as community members, and what will this do for our transportation options moving forward for the next decade and our environment and our communities. So Joby Aviation, who are we? So we're a vertically integrated transportation company. That is a mouthful for we do everything in-house. We are an aviation company that is bespoke to every component you see on that aircraft. Everything but probably the wheels, I think, are in-house, designed specifically for the unique specifications and needs and technology that we have in-house built. We develop, we manufacture, and we will operate this revolutionary aircraft. I'm sure you all have read some of the news as well, we'll manufacture, so we will get a little bit into that. Targeting FAA commercial certification to begin FAA certification for commercial service around 2025, remaining our goal. Again, beginning at what I would call the existing aviation infrastructure, airports, helipads, et cetera, and then growing the network out from there. And we are currently at about 1,800 team members. To give you context, when I started about 3 years ago, we were at 800 team members. So it is a rapidly growing company. We started, I think, when I started, we had about 2 aircrafts. We're on our 4th, delivering, I think, another 2 very soon to the military at Edwards Air Force Base. So we continue to grow exponentially. Where are we? We have 3 major facilities based in the Central Coast area. Our main headquarters is in Santa Cruz. That's sort of the administrative offices, some prototyping, have about 300 or 400 employees there. San Carlos is the exciting battery production facility. That's where we take folks that are bored from working at other battery companies and want to do revolutionary work, and maybe other EV companies and want to apply that to aviation. And we have scaled up there for about 400 employees as well. Full production, all the battery, we built all of those in-house. You will see all the battery components, all the wiring being done manually there in-house in San Carlos, which is right near the San Francisco airport. And Marina, that's really the mothership of excitement, where all of the components come together for this aircraft. It's our major facility where we do our manufacturing. We have the capacity to build 25 aircraft there. That is where we do our daily testing of our aircraft. So you happen to be in Marina driving by, you will look up, you will daily probably see us flying around. It's also an interesting testament to us as a company, and I like to remind folks, sustainability is at the core, and we picked one of the most beautiful ecosystems in all of California, the coast of Monterey Bay, where the environmental protections are at its core, and we're doing aviation testing, right? So I've learned as a policymaker a lot about turtles, monarch butterflies, less churned leaves, the Sanguilia leaves. But again, it's about how do we incorporate ourselves into these communities, into these regions that they are, and bring aviation that they're not traditionally accustomed to. Because again, we've eliminated the nuisance of noise or the nuisance of emissions as communities traditionally have been used to. So that's where we are sprinkled around. And with that, maybe I can jump into what we have built.
Marina traffic, experimental 542, Bravo Juliet. We'll be taking runway 29 shortly. There's one side of the runway coming back to center line.
Go if your checklists are complete and you're ready for flight. TC's go.
Controls 1 go.
EP1 go. Batteries go.
Scribe 1 go.
Scribe 2 go.
Limits for flight confirmed. You are cleared for flight.
Copy, picking up. Airborne, 30 knots. Big D sail to stop. B-45, settling, expected. Ground confirmed.
So proud of that crew. They are doing that right now. They are doing that right now in Marina this morning, and I had to come down here and spend this wonderful time with you all. Thank you to George for that great kickoff, and thank you to Cindy and the Western Museum of Flight. Very honored to be here speaking with you today about a company that I joined a year ago. I was probably a little bit of a skeptic, but really realized that this stuff is real, and we are really making this happen. To fill you in on how Joby began, we started as a very small company, even before we were officially Joby Aviation, of some really smart people with our CEO and founder, Joe Ben Bivert, who were building sort of small, experimental, radio-controlled sized airplanes, just sort of branching out and saying, could we do something? Those designs are really fascinating and incredibly diverse. But a design sort of solidified where this was the best configuration for an electric vertical takeoff and landing aircraft. eVTOL is what we call that. So from about 2015, they started to look like they do now. In 2017, we started with a full-scale demonstrator. This was not something that a human could fit inside, but the next one that started in 2019 grew to the size that they said, well, let's put transparencies on it. Let's make this something that a human could actually get inside and fly. That aircraft is what you just saw on the video. We built 2 of those prototypes. We've moved on now to a third pre-production prototype that's demonstrated here in blue. This is the full-sized vehicle that is what we are taking to the FAA for our conforming type certificate. It is the actual ones to the far right there haven't started rolling off the assembly line. Right now we're just building these prototypes. The second one is flying at Marina today. The third one will fly at Marina this week. The fourth one is sitting right behind it on the assembly line, and the fifth one is back in pieces starting to come together. It's really neat. It's a real factory. Very, very impressive place. So when you see the videos and the pictures, there'll be a mix, and I'll try to point out which vehicle is which. Very hard to tell the difference unless you really know some key things to look at, kind of like if you're a car person and you're looking up close. So we call this vehicle the S4. The JAS4-1 is the first prototype vehicles we're working on right now. It is a piloted vehicle. I'll get to a little bit more detail about that in a moment, but what we're going to take to the FAA and bring to market, we'll have a VFR pilot in the front. That's visual flight rules. We're initially not going to certificate this aircraft for flight in instruments. We'll do that second. We'll move on to other technologies as we begin to progress. But as a stepping stone, it was easiest for us to start with a VFR day and night aircraft. The pilot sits up front. There are 4 passengers in the back. It's all electric. The entire thing is run off of the same set of batteries, which I'll speak to in a minute. There aren't extra little 12-volt batteries tucked away and all that. It's all running on a unified electrical system. It weighs about 5,300 pounds. To give you a comparison, this is very much like a Beechcraft Baron. And if you know anything about the Baron, the BE-55s are pretty much 4-seaters. The BE-56s become about this weight and kind of put a 5th person wedged in the very, very back. And the BE-58s start to get to 6-seater airplanes, so at a little bit of a heavier weight. But just to give you a sense of the size and capability, that is about what we're looking at when we talk about useful load. When we talk about speed, the marketing people like to make me say 200 miles per hour. That's a maximum speed. We're going to operate slower than that in something that's much, much more efficient. I imagine like Cessna 172 type speeds. If you're going 115-ish, miles per hour, well, that would be nuts, maybe 130 miles per hour, you can get across the Los Angeles basin in under an hour, and that's sort of the sweet spot, I think, where the market will find itself. 100 miles, that is well within, so again, if you're going about 130 miles per hour and you're going for about 45 minutes, you get into those types of distances. Across cityscapes, not for short distances, it wouldn't make sense in a marketing sense for that. And we will be using certificated avionics in this aircraft. I'll speak a little bit more about that in a bit. So I like to talk about the S4 in a factors of 12 type of arrangement. And this is where we get our redundancy. It has 6 propellers, okay? There's redundancy built into those in that every propeller is run by 2 independent AC motors. So they're DC batteries, because that's what batteries are. We use quad inverters to produce AC power, which is then controlled through our flight control laws into those 12 motors that run 6 propellers. The aircraft will fly fine on any 4 of its propellers. It has 4 battery packs, each which is feeding 3 of the stations. It has dual redundant network systems in it, running triple redundant triplex vehicle navigation computers, vehicle sensor computers, and other small computers that we build, as George mentioned, in-house. Everything is vertically integrated in order to keep our weight down and keep complete control over the pieces and parts we put into this aircraft. We design and build them ourselves. Let's see, I mentioned the 6 propellers. The redundancy there, if any propeller for whatever reason was lost, again, dual motors, so this is a fairly far down the failure chain. All of the motors are rated to 150%. So if you have 6 of them, 6 times 100, you have 600%, if that's a math thing you can do, worth of power and control available. If you go down to just 4, they each go to 150, you're back at 600%. That allows us to have both the performance and we believe the handling qualities as well. So an engine failure in this type of vehicle is actually going to be quite safe. The pilot will have no action other than, well, we should land now, and that's all. Our charging system is pretty fascinating. The Geeks is its own proprietary system, but we've allowed it to go out into the rest of industry. If anybody else wants to adopt it, we will allow them to. If you're familiar with superchargers and other types of charging for EVs, there are several different types and versions and power supplies that are required, whether you're at home or whether you're at a station. And we had to consolidate that down into our own system. One of the interesting things is the batteries are not just charged, they are conditioned as well. And when we say conditioned, we mean both heating and cooling. It goes both directions. This is so that we can keep the batteries at a proper temperature during the charge cycle, which typically takes us about an hour. We come in from a flight, give the crew a break, we maybe do some debriefs. Some of our mechanics and some of our engineers go off and charge the aircraft. About an hour, hour and 15 minutes later, we're taking off again on another flight. Now those are to full charges, and that is with conditioning that is known to say we want this battery ready to go for our standard test profile, and that is with a very, very warm battery. Batteries are more efficient the warmer that they get. If they get too warm, you don't necessarily want that. But we do want our batteries to be well conditioned, not necessarily cold, fresh out of the refrigerator. If you store your batteries in the refrigerator, it actually works, but you can't necessarily take them out and put them in a flashlight and get performance right off the bat. So our charging system is all automated. Power, cooling or heating fluid, and data comes out of it as well. And it's a very quick insert system that works. Speaking about the batteries, they are running at, they are 35 kilowatt hour batteries, but 4 of them. That is altogether more than any of the electric vehicles that you're most common to see on the street. If you're familiar with a very large, boxy stainless steel truck, that has a smaller battery, but it also weighs more than we weigh. The cockpit is, like I said, is going to be commercial, certificated, TSO'd avionics. This is a Garmin suite. We've partnered with them, and what you see here is their G3000. That works very much like you expect for any of the pilots in the room, like any of the other Garmin glass cockpit that are currently on the market. Very, very similar. We do have the way to tap in through Garmin and put some of our own software and displays on those as well. So we're working very closely with them to either tweak their displays to our needs or to give us the space to use their interface to show things that we want to keep control over, things like our battery systems and health and usage monitoring. Let's talk a little bit about the flight controls. You see there on the bottom, we have a left-hand inceptor. It's not a throttle, it's a left-hand inceptor, and a right-hand inceptor, which we do call a stick because it's easier than saying inceptor all day long. So stick in your right hand and left-hand inceptor in your left. The way that our control laws work is fully unified. This is a simplified vehicle operation system. It allows us to have a relatively untrained pilot, well-trained, I should say, but not in the traditional sense, pilot, fly this vehicle very safely. It doesn't have a stall because the unified control laws immediately bring the propulsion back up into the vertical mode and will hold the aircraft from getting too slow in a traditional fixed-wing airplane sense. The left hand controls your faster and slower, your forward and back. So when you're in a hover, if you wanted to move forward, instead of a helicopter would use the right hand, in our aircraft you move forward with your left hand, you move aft to stop or to go backwards. In a hover, the forward and aft on the stick is up and down. That seems a little bit strange to some helicopter pilots, but it works very, very well in forward flight because that is always a pitch or a, in our case, height rate command. Left and right is very intuitive. It does left and right just like a helicopter does. And then the right-hand twist is where we get our rudder or yaw type control. So in a hover, this would be pure hover yaw translation. And in forward flight, that would be like side slip, like putting in a little bit of rudder for crosswind landing corrections or anything like that. Now, on the left side here, we see our chief test pilot, Buddy Denham, and one of our other top test pilots, Zach Reeder. They are flying in a remote cockpit. This is sometimes gets confused when I talk to people. They say, oh, you're building that one that doesn't have a pilot in it. There are some companies that are, but Joby, like I said, will have a pilot in this aircraft. However, when we're doing high-risk build-up type things, because again, that company grew from little radio-controlled airplanes that nobody could fit inside anyway into something that was much larger, we already had the remote capability in-house. And we typically fly our early prototypes in a remote environment, or anytime we're doing high-risk testing, the type of thing where the pilot might be wearing a parachute or wish they had an ejection seat, excuse me, then we would fly that remotely. But this is not what will ever go to market, okay? Very clear. This is just a flight test capability. It's a tool. And what's interesting is the flight control laws, the computers on board, really have no idea that the pilot isn't right there. It's all the same inceptors, it's all the same controls. There's just a radio link that sends that from what would be the inhabited pilot cockpit to the aircraft itself. And so there's a very slight time delay, but otherwise the aircraft is just as happy, very much flown as a remote piloted aircraft, an RPA. We don't have a whole lot of automation right now that does any sort of fancy fly home type things. We do have that capability, but it's not particularly fancy. Okay, so far I've been talking about my team. I've got a team of about 40 individuals now. I'm growing it to be much, much larger as we move towards type certification and a lot of demonstrations that we have with these vehicles. But the company, the 1,800 people that George mentioned, are doing fascinating stuff all over. And I love talking about it because it's really, really neat to see that, let's see, how would we build some sort of a test rig for our propellers and our motors and our tilt systems? Well, they went out and they built basically a circular roller coaster. We call it Whirly. And it used to just power itself around the track. Now Whirly is actually powered, so we can put different types of loads on. And all of our prototype propellers and electric system, EPUs, electronic propulsion units, and our tilt systems get fully tested in Whirly, both for initial loads and flutter type concerns, but then also for reliability and maintainability, run them out for as many hours as we can put on them. We have rigs like this all over the company. Things like, flexing wings or doors, just amazing stuff, smart people. Sometimes it looks in the prototype phase like they built it in their garage, because they probably did, and then later on maybe it gets painted blue and it looks much more professional. But to give you an idea, when you see any of these shots floating around about Joby, this is, for me, the most exciting part of the company, and I work on the flying side. Okay, George mentioned that we are partnered with the AFWERX Agility Prime. This is a Air Force run program where the US Congress has given some money to see if these things have any, if these eVTOL aircraft have any military capability, and kind of keep these companies fed with a little bit of seed corn. So this is our first prototype of the pre-production vehicle. This is what we call serial number 5. It arrived at Edwards Air Force Base last September. It has flown several times out there, and it'll get ready to fly again next week after some modifications, both the hardware and the software that we've done. But pretty exciting. This is in the historic hangar. If any of you have ever been up to Edwards and taken the tour, we were first housed in there before they moved us to a more permanent facility. And we're in with some, there's an F-117 in the back and a P-80 and some just really, really fascinating artifacts. Great museum if you've had an opportunity to go up and check it out. Just to prove to you that it is flown, there it is up and away, hovering at Edwards. Okay, so noise is a big thing. George is going to talk about that some more, but I wanted to give you an opportunity to see some of the flight test work that we've done on this. We've done several types of surveys, and it's very impressive how different the noise is. Noise is a funny thing. If you've studied it at all, we measure it in decibels. Decibels are things that humans can't really think about very easily. You got to be a bit of an engineer mind. And so when you see numbers, it gets really, really difficult and fuzzy. This is a great demonstration of how we've been able to reduce the noise in the vehicle by some really, really trick engineering that I'd love to chat with you about at a different time.
So thank you for listening to that or not listening to that. I think two things to take away from those videos. One is it's the peaks and the valleys that are really the disturbances in the noise profile, and what you notice is the consistency of the Joby's profile. I think that's something to take away. And second, this is sort of really key when we talk about helipads, for example, in New York. The ability to just press the button and Brian just takes off, just the same way your Tesla or your Prius. There's no wound up time, there's no rotor roll up time. You know, the 8 minutes of noise that most communities are hearing when propellers are going, that's not something you're going to be accustomed to, or your customer is not what you're going to see on the Joby aircraft. So, and then just to step back, the reason I like having Brian kind of give the presentation in the middle is because it really highlights that this isn't just a small startup in the valley or two guys in a garage. We have spent a decade not just working on the certification, but everything to the detail of the acoustic profile of our aircraft, to the pitch and to the torque of the propellers, to the distance between and the width and the angles of each of those components, all contributing to design this revolutionary product. And why is that important? Because I can then walk into elected officials and regulators and local officials and explain, this isn't a drone, this is an aircraft. This is the same way when you enter any other aircraft in a commercial flight that you're used to, we are going through that certification process, and that safety element and component is at the core of our company. So safety and sustainability are at the essence. And one thing I'm gonna try to not to mess this up and jump back really quick to that picture of the Whirly. When we talk about sustainability being at the essence, it's not just about creating a quiet plane that has zero emissions. That is a rock quarry that we installed this propeller Whirly in. That rock quarry, we took the conveyor belt, and most of those columns that you see are actually refurbished and reutilized from the old quarry system that we then repurposed for our actual Whirly aircraft system. So when we talk about sustainability, we are really implementing that even in our actual products, from the land that we use to the aircraft that we build. So it's a wonderful story to be a part of, and again, it's in the Central Coast, and it really continues to relive the values that Joe Ben was at its core of creating this company. So back to the what does this mean for you? Because we've created this incredibly quiet aircraft that's 100 times quieter than a helicopter, what does that mean? If you hear a helicopter for 100 blocks or an aircraft for 100 blocks, you will hear the Joby for 1 block. That is what it means to be quieter. That means we can change the dynamic of where we can take off and land these things. If this thing is as light as a Model 3 Tesla, or lighter, depending on who's in it, and it only takes the charging of 2 Tesla superchargers, you can imagine the spaces that we can utilize and leverage, whether that's existing aviation, existing heliports, existing helipads, to rooftops, top floors of parking structures, top apartment complexes, places where traditionally weight, fire response, those were complex issues that we are now repurposing and reconfiguring to leverage that to ability to bring electric aircraft. That's one reason New York, the EDC, the Economic Development Corporation of New York, that owns 3 of the main helipads in New York, is saying, we want to electrify these helipads. They invited us out to do a demo. I won't show it to you. LA is better than New York for now. So we will show the LA, we will have an LA demo, and that will be our mark. But it is really the impetus. You're seeing communities come to us and say, this can change the dynamic of where I live and the way I actually communicate or commute from work, right? Where you have in LA County, for example, just we're at Torrance, but you've got Whiteman, you've got Whiteman, Van Nuys, Burbank, Santa Monica, the network of general aviation airports, Ontario, commercial airports as well as general aviation airports that are underutilized in this country because of either nuisance or because of NIMBYism. We have the ability now to repurpose those locations and bring this electric flight. So what are we bringing? As Brian mentioned, there's different companies doing different things. Joby's goal is to bring you the electric rideshare service, an on-demand service once we are at full scale, where you will be clicking the button, calling an eVTOL, having that pick you up and take you from downtown LA to Los Angeles Airport in anywhere from 10 to 12 minutes. The ability to do this obviously is once we're at full scale. And again, we will start up at existing infrastructure, but these times are actually tested, flown with helicopters, flown with other craft, done the passenger movements to validate the trip times. And again, this is the proposition where we're able to deliver this service at scale, hopefully at around Uber Black pricing at a $5 a mile. So each passenger pays somewhere between $50 or $60 to do that downtown LA to LAX leg. Why do we think that proposition makes sense? For us as a company, those are rides that should be taking you 30 to 40 minutes and are taking upwards of an hour, if not longer now. We're not eliminating congestion. We're giving an additional toolkit for you as an option. We're taking that 80% of that leg of that trip that is the most complex, the most difficult, and eliminating that and reducing that time frame. So whether you walk to Union Station, whether you bike to the Van Nuys Airport, and then you hop onto the eVTOL, or you go to Dodger Stadium, or you go to any other facility downtown and you hop on the helipad and go up to the top floor, that's the idea, is to seamlessly integrate this into your existing transportation network. The goal isn't to replace what you have, but to be additive to what transportation planners have as options in their toolkit. So we've mentioned throughout this remarks the various partners we have. Delta is one of our key partners, and again, the value proposition is Delta's looking at sustainability efforts. They're looking at integrating sustainable aviation fuels. They're looking at the global metrics that we all have set with ICAO on sustainability and zero emissions, and are looking at Joby as sort of a complement to that, as well as an additive service. Because as anybody knows, for example, if you want to get from Van Nuys to LAX, it could probably take you anywhere from an hour and a half to maybe 30 minutes. Depends on which time of day you're leaving, right? So I think the ability to have that home-to-seat service is one of the components that Delta's looking at. Uber is another key partners of ours. Uber is helping us with the data and the demand analytics that we are looking at in terms of where are we locating these nodes, where are we locating the transportation demand centrics, where we are going to be able to move the passengers for these sort of short legs. And ultimately, this is the vision that you will see smaller footprints at existing airports or at existing locations where you won't have multi-billion-dollar rail lines or bus stops being developed, but small integrated centers like this where you're coming in, checking in, and hopping on your aircraft to make your ride share and connecting to your additional node at your last destination. So with that, I think I just wanted to say thank you again and open it up now for questions that you may have. Just to repeat the question, is Joby looking at charging at different locations so that there's a network for folks similarly to what Tesla did with EVs? The goal for our facilities, our infrastructure, is at any of the takeoff landing locations, we will have charging. That's something we are working with the various FBOs that we've partnered, the various sites, helipads we're looking at, is incorporating that charging, updating ALPs at various airports, working with those institutions, working with the power authorities to bring in that charging grid capacity. And then we have our own charging, like as Brian mentioned, our own thermal conditioning dual system. The Geek system will be installed there as part of it. So that system has the capacity to dispense CSS as well, so you'll be able to incorporate both if necessary.
That's great to hear. The other half, are you at Torrance?
At Torrance, yes, we are. Yeah, no, that was a good advertiser for the amount of available charging and solar as well as space hangar available at Torrance. We are definitely looking at all locations in the county as we expand the footprint, because I think you're right. I mean, these are going to be the starting grounds for where these aircraft are going to take off and land. And I think the one value proposition we didn't talk about is traditionally the difficulty of having pilots is the ability to end up spending time away from home and travel. This now opens up that network so that locations like Torrance, you can have pilots flying, staying in Torrance, living in Torrance, and being able to provide that pilot rideshare service.
I'd like to talk a little bit about the technical side of that as well. When we talk about infrastructure, I mentioned the battery charging system and our conditioning system. It's very important that the vehicle is always dispatched on a known flight so that when it comes into land, the batteries have naturally, from being used, heated themselves up to right to the point where they're most efficient for the landing phase, which is when we are usually a little bit energy deprived, well, we're definitely energy deprived from our takeoff phase. And so there's not really a use case where this vehicle will be sent out and pick you up in your yard. It'll never do that. That's a regulatory nightmare. And so it'll go to a vertiport where it will get a charge and condition, which can take, just like EV ground vehicles today. If you only need a couple miles, if you only need a little bit of temperature change, you can plug in, boom, while people are getting in, while people are getting out, unplug and dispatch that vehicle on a relatively short leg. Whereas if it needs to go on a very, very long leg, maybe it does need to spend extra time on the ground. And that's where the app will come in, and it'll help do that math to say, okay, somebody has already told us that they're on their way and they're going to be here in 15 minutes and they want to go all the way across town, and that vehicle's coming into land. When it lands, plug it in, give it this much charge, and condition the batteries to this state so that when they arrive, they get in and the vehicle goes off and performs that specific mission. So dispatch is a very, very important part, and that's where the data comes in. George mentioned our partner Uber. We're getting a lot of that information about how people move, how quickly they make decisions to move. It's a fascinating part of the business. Yes, in the back, go ahead. Yeah, so the question is, are there other airlines out there that are looking to partner? And the answer is absolutely yes. There are lots of deals going on throughout the industry. We use them as opportunities to say, ooh, look at us, we have money, we have backing. So absolutely, who knows who the partners will be in the future. Delta is our partner today, and who knows how these services will all go. But I think that's a big part of, like George mentioned, and you saw in the video, the ability to move people all the way to their eventual destination is important. And if you could land at the Delta terminal, that's a whole lot better than landing, off at some parking garage and then having to make that extra last mile step there. So good question. Go ahead. Yeah. So the question is about special pilot training, special maintenance training. Absolutely. This is a new and novel concept. We're not the only company trying, but we have to set ourselves up for success. So we have a Joby Academy that is already in operation in Watsonville, California, where anybody off the street can come, just like any other Part 141 school, and get some pilot training. That is in a traditional sense for now. When we have S4s that are ready for pilots, then we will be training them towards essentially a type certificate. And so they will be specifically checked out in S4s with unified control laws, type rated in the S4. Whether they come from a fixed wing background or a rotorcraft background doesn't make too much difference, because the vehicle is so unique, and the training program, which will include level D simulators and lots of classroom work, was all built to take whatever you knew before, leverage it, right? You know how the airspace works, you know how the communications works, how to speak on a radio, how to navigate. That's all taken care of and wherever you came from. But operating the S4 is going to be a type rating. Yeah, so it'll be powered lift. There's been a lot of changes in the industry about how the vehicles are certificated and how the pilots are certificated. Right now, the pilots will carry, after their S4 type rating, that'll be a powered lift license, we believe. Not a lot of those licenses exist right now because there's not a lot of tilt rotors, which was why it was originally envisioned for things like the V-22 is still just military, doesn't require a license, but when the Augusta 609 arrives on the market, that will require special training and a very, very similar license or process that we expect to have as well. So, yeah. The aircraft will be certificated up to 15,000 feet. There's where we get into oxygen limitations, but that's probably well beyond where it'll be most efficient. Couple thousand feet, much like you would, if any of you fly from here and go over Santa Monica through the corridor, that's probably our happy place. 3,000 or 4,000 feet is where I would guess. I don't know if you've got any other input from the regulatory side.
No, that is correct. I mean, we want to go high because ultimately it'll be more efficient for the batteries, but also it's less of a nuisance. And when you were looking at those noise profiles, those were all at about 1,500 feet. So that gives you a sense of what the impact would be.
Well, currently we plan to operate just as any other VFR general aviation aircraft. We'll be able to do that. That's not a problem. Certainly. Yes, I mean we'll probably at first be operating in the same rules that any of you are operating in. Eventually, when this goes to scale and there are lots of these vehicles from lots of companies and lots of operators, then maybe that's when the airspace will have to change. But when there's a couple dozen of them, I don't expect there'll be much impact as far as the operating area. We'll be sneaky though, right? The way that some general aviation pilots are really nervous about flying around the LA basin, it's a very complicated airspace. Those of us who have grown up here and flown here and know it well and are comfortable, we know how to move around very, very efficiently. Some people aren't able to do that because it's not at their comfort level, but we will be training our pilots to take advantage of those small corridors, those open spaces in between airspace, so we can really, really be efficient. So those are all available on YouTube. If you just look up YouTube Joby, they'll be available on there, and you can catch them all, and you can put a headset on. You can really, really listen to them carefully. I'd rather not waste the whole audience time with that right now, because it's a lengthy video. But what's yeah.
Yeah. So from the NASA testing that we did, the NASA study reported that it was about 65 decibels at takeoff and about 45.2, I think, in flight. So pretty much inaudible. To give you context, like, you know, the helicopter's a lot hot, like I think 90. So yes, the acoustic hemisphere sort of, it's a lot smaller footprint, and that was the idea with the sort of New York travel, is to show how large that impact is as you're landing versus as you're landing with the Joby, kind of the distance that impact is felt. In terms of if you've got multiples of these aircraft, I guess the question is, if there's multiple aircraft operating, what is the noise profile, I don't believe we've done an analysis for sort of several aircraft simultaneously, but I think the idea would be exponentially similarly quiet, right? Because you're still completely inaudible. So if you have 10 inaudible out, I think one thing to take away is it's not the same as a drone hum. I think that was the thing that NASA was focused on, is it's not an additive noise the way you would have a buzzing or a whipping of a drone. It's a very distinct sort of vacuum sound is what they actually referenced in the actual NASA study. So, yes.
When do you project introduction of service?
We are looking, the goal right now, what we have targeted and working with the FAA, and the FAA has announced, is we are working for commercial certification for commercial service in 2025. So with one of the aircraft, as Brian was mentioning, already delivered to Edwards for testing, another 3 coming off the assembly line. And I think to the point, I think earlier about working with regulators, this is something we're working very closely on the airspace, working with the Federal Innovate 28 team, as well as the FAA Air Traffic Control team, because this isn't gonna just show up the way bikes and scooters did, right, on your neighborhoods. This is gonna be something we're working lockstep with regulators, developing those LOAs for the long-term, next 5-10 years, but in the interim, beginning those operations with the existing regulatory framework within the existing national airspace.
Yeah, I'd like to, on the when we'll be certificated, that's really determined by the FAA when we'll complete that. We're already well underway, and it goes much, much more than the aircraft itself. All of the parts have to have manufacturing allowances also. Joby has a Part 145 repair station. We have a Part 135 on-demand charter that's already up and operating. So all of these stages go in bits. George is correct that we have lofty goals in Joby. We don't necessarily have total control over that, but I am confident that there will be some forms of commercial service in 2025. That is a hard goal that my organization is supporting.
Correct.
And are the motors and their inverters either liquid or water cooled?
It is, yes.
Yeah, so they are not cooled in flight during the conditioning process, and so it's heated or cooled, depends on what you need, right? But yeah, so we condition them on the ground, and then once that charging plug, the Geek system, is unplugged, that fluid does circulate, but it's no longer actively conditioned further. The batteries are pretty fascinating. We have our own quality control system. We do source the packs from outside, but then we have our own way of saying these are really good batteries and these are acceptable batteries and these are not. And then we build them into our own, from the cells, those are the cells I'm speaking of, all the way into our 4 battery packs, which are individually contained as well. We have a lot of containment systems to make sure that those are extra safe. But that's a whole nother really, really fascinating part of the science and the engineering that goes in. It really is, right? And I don't need to tell a group like this that energy density is a challenge. The physics is something that we have to overcome. But it's pretty impressive what we're doing with surprisingly lightweight systems right now. So.
Can you reveal what the target cities are for production?
Yeah, we've talked about Los Angeles and New York being key markets. We're looking at major urban cores where there's congestion, and this value proposition is really the ability to get you your 1-hour trips in 10 minutes, right? Trips that should be taking you 20 minutes. So this gives you that additive option. It's not replacing your daily service. So. 5,800?
5,300 pounds. That's where I was talking about. Maximum gross weight is very much like a Beechcraft Baron. Very similar in that weight class. Of course, you don't burn off fuel, so you land at the same weight that you took off at, which is an interesting consideration.
Yes, far corner. The question about what happens about remote flight, I'll let the pilot answer.
Yeah, so the certificated vehicle will not have any sort of protection. This will be a single-piloted airline type aircraft. So a lot of airlines already operate single-piloted, so this is not something that's totally new. When you think of getting on an airliner and you see two pilots up front, well, that's a different decision, much bigger, different unions, things like that. But no, single-piloted, and no remote capability is designed into it. That is purely a flight test risk reduction tool.
One back there. I'll let you answer.
Okay, the question was about the Garmin Autoland system, and it follows up with the previous question about what happens if the pilot is incapacitated in some way. Great question. That is for later stages. We are absolutely looking at technology. We recently purchased a company called X-Wing that is flying an autonomous Cessna 208 Caravan. A lot of that technology, I'm sure, will be leveraged into later projects. That's not something that I worry about on my side of the company, because I'm all about trying to get the current design safe vehicle through the process. There's no doubt we will have other type certificates rolling out of our factory in the future. So anything is possible. We're certainly not looking at that stuff. It's just that the focus today is on, let's just make something that's single piloted, VFR, get it to market, do the rest of the work. Yes, Abigail.
Yeah, an operational question. I'm assuming that you guys have talked to Lala, and also as a weight question.
So in terms of the question of operation, how do we operate in and out of LAX, I think is the broad question. So we are working very closely with the airport as well as with Delta in developing what those routes are. Some of you remember LAX used to have a helipad at Terminal 4. So we are actually working closely with them to determine whether you land sides non-secure, secure side. Do you land on top of the terminal? Do you land at a parking structure? How does it work within the existing people mover system with the existing rental car facility? So we are in close coordination with them, because ultimately that's the goal. Is they actually put out an RFI about a year ago that we responded to and provided about 200 pages of ConOps of exactly how we would provide that service at the parking structure P3 directly across from the Delta terminal, what two landing facility, takeoff landing spots could look like. So that is something that we are currently in process, developing the charging, working with DWP. In terms of, I think, the question of the weight, that's all part and parcel of that. If the service is going to be specifically for Delta customers versus is it somebody who is coming that wants to be adjacent near LAX versus people who are going to be traveling and using the LAX for another connecting flight, for example. So they'll have two different types of services or different types of bespoke services depending on the type of customer.
And the second half of that question was about weight. And yes, we will have to be very conscious of weight, there's no doubt. But that's true of any small aircraft, and it is a requirement for the pilot, for the operator, to run a weight and balance for any flight that you're on. So how we do that, the most obvious way is just measure and actually know what people are carrying, how much they weigh individually, where they should sit in the 4 seats in the back. Don't know if it was obvious there. One of the other things I should mention, if you've ever flown small general aviation airplanes, a lot of times there's maybe one door, maybe two, or there's definitely one, maybe two doors, and then you have to sort of crawl your way in. This has 4 doors, and so only the pilot has to do any sort of gymnastics to get up into the front cockpit. The other people have their own door right there. Much like a helicopter, it's very nice and comfortable to get in and out of. And there's a baggage compartment in the back. Yes?
So, LA is hosting the Tuning. Is Joby looking into integrating into that at all?
Yeah, we are talking to actually the LA Touring Committee as well, and we got to be privileged to be a part of the Olympic flag welcome ceremony with Delta, so it's definitely something we're looking into. Again, just keeping in context, they're looking to move thousands and thousands of people, and we're looking to move a couple of hundred people within these aircraft, right? So I think, and making sure that we're not impeding on the airspace, but our goal is to be at full-scale operation, and there are other companies out there that are aiming for the same target as well. Repeat question in the back. Yes. Yeah.
Yeah, the question is a multi-engine aircraft. This does appear to be multi-engine, and it in fact is. We currently require multi-engine licenses to be test pilots in it. But as I mentioned in the redundancy part, in the very, very unlikely case that you ever did lose one of your 6 propulsors, the other 4 remaining, because that one that was lost, its partner is now asymmetric, and it has to tune itself out of the control laws. It's still active, it's still there, it just can't do much because it's asymmetric. The remaining 4 are now up to their full 150% think rated power, so that you can continue with the same control laws, the same handling qualities that the pilot had before. So it will be an emergency case, you will be heading to land, but the pilot is not challenged by any sort of asymmetry in their controls. We expect that we will be able to fly it as aggressively, if you should say that, as if you had all 6 propulsors working. Now, will we? No. We'll probably say, hey, the smart thing to do is conserve all the energy you can and fly very nice and comfortable, which, by the way, is going to be the profile anyway. We're not going to be making people sick in these vehicles. We're going to have to fly very smooth, very deliberate, very energy conscious at all times. So I believe that a OEI, one engine out type scenario will be a non-event for the pilot. Very easy to train. Yeah. Yes, sir.
When you transition, do you phase the engines in the rotation or not?
So the question is about transition and how we phase the motors in transition. Unlike the V-22 Osprey, our nacelles can tilt in any position that the flight control laws feel that they need to be. It's a model following system, and so it knows how the test pilots taught it to fly, and it tries to fly like the test pilots taught it. So when we fly the simulator and then we fly the vehicle and we say, it flies like the simulator. Yeah, because it's flying with the exact same logic inside of it. So what the nacelles are doing, what the tilts are doing, is all in the background. The pilot has no thumb wheel, no lever, no control over that whatsoever. The vehicle just says, the smart engineers got together and said that when you're going this fast, at this much angle of bank, at this weight, then your nacelles should be like this. And if you need to be turning, then maybe one goes a different direction or a little bit of yaw. They're all entirely blended, and it is a fascinating aircraft to chase. Following behind it and watching it do its work is really neat, because sometimes it'll make decisions that you think, I don't know that I would have thought of that if I had the controls myself, but the computer said, you know, the best way to get the moment that I want in order to provide the roll or pitch rate is through something pretty magic. Yeah.
We actually have announced our interest in building a manufacturing facility in Dayton, and so in Springfield we are partnering with the NAMC over there, the National Advanced Air Mobility Center, and working on developing sort of local pilots, working on training, sort of building the legislative community, building the sort of ecosystem. But specifically in Dayton is where we'll have our manufacturing, and then in Springfield we'll have is where we have our simulator, our full 18-wheel fuselage simulate trailer that we do training for pilots as well over there. Yep.
In the Dayton area, we'll do production flight test, but our plan is to keep flight testing at Marina and any other partner locations. Someday, absolutely, it's totally possible that we'll do experimental and developmental flight testing in the Dayton area, not on the plan at the day.
Yes.
And when will flight, how much of the lift comes off the wings?
Wingborne, something like about 80-ish to 100 knots. The nacelles come completely down, and at that point you are entirely wingborne. It is blended all the way down into, obviously, 0, and it'll do whatever it needs. Now, what's interesting is some of the control laws will sometimes, even when you are wingborne, the tilts will sometimes come up a little bit because it says, you know, I could use a little bit of extra moment right here. So that's it. Okay, I think we have time for one more question. First hand up. So the question is about technical challenges between our prototypes and what we're going to take to the FAA. Honestly, there's always going to be minor things, right? Test pilots, test engineers are always finding problems. We're always trying to fix problems. Eventually, some program manager has to make the decision that that's good enough, and we go to market with what we have. So we fully expect someday that program management decision will be made for us. However, the vehicles that we are flying right now are already the size and weight and have FAA conforming parts in them. It's not the entire aircraft yet, but we are getting production certificates on these pieces, parts that are coming together, and the closer we get to a full aircraft that is production certified is when we'll be able to take that and get it type certificated. So challenges, yes, but we're already pressing on what we think we're going to take for score with the FAA, so it's pretty great. Well, I'd really like to thank you for the time. I'm very impressed that we went as long as we did. This is wonderful. But George and I have appreciated the invitation, and we'll be available afterwards for any other questions that you have and that type of thing. Otherwise, if you look up the company online, you'll find a lot of the same types of information that we talked about here, probably a little more refined than either of us spoke off the cuff. So there you go. Thank you.